All right, we're going to be looking at notes for section 3.1. In section 3.1, we're going to be talking about long division to start with, but then we're going to be talking about how to divide using a process called synthetic division. And this is going to be fundamental in everything that we're going to be doing in chapter 3, so it's going to be important that you get this concept down. So for long division, we're going to go back to elementary school, and we're taking 7,345, and we're dividing it by 3. Now we can put that in our calculator and get an answer, but you need to understand the process of how long division works. So remember, with long division, you're taking the 3 and seeing how many times it goes into the 7. So it goes in twice, and then you do 3 times 2 is 6, and that's what we put here. And then we subtract those two. Then we carry down all the other numbers. This is how I like to do it. So then for the next step, we're looking at the 1. 3 doesn't go into 1, so we look at 13. Does 3 go into 13? Yes, it goes in 4 times. So 3 times 4 is 12. Subtract these two numbers, we get 1. Carry down the 4, carry down the 5. Again, we're looking at the first two numbers. 3 goes into 14 4 times. 3 times 4 is 12. Subtract that and you get 2. Carry down the 5. 3 goes into 25 8 times. That's 24. Subtract those two, you get 1. Now we're not going to be dealing with decimals, so this is our remainder. So when we write the remainder, we write the remainder as 1 over 3. So 1 over whatever we're dividing by. So in this case, that is our answer to the problem. Okay, so here's another example. If I divide using long division and I have polynomials, so basically I'm saying, what is 6x cubed minus 16x squared plus 23x minus 5 divided by 3x minus 2? Okay, so what we're wanting to know is, can I divide this evenly? If I factored the top, would this be a factor? And so we're going to do that by long division again. So we're going to focus on the first two things, 3x and 6x cubed. Now make sure that when you're writing these numbers down here that you've represented every possible polynomial power. So x to the third, x to the second, x, and then x to the 0. So we're looking at just the first terms. How many times does 3x go into 6x cubed? Well, to get the 6, I need to multiply by 2. And to get the x cubed, I need to multiply by x squared. So this times this is 6x squared. But then I also have to multiply that times the second term, like a distributive property, right? So basically I'm saying 2x squared goes into 3x minus 2, and I'm distributing. So that's where this 4x squared came from. And then I have to subtract this minus this. Sorry, that should be cubed. This minus this is 0. And then negative 16 plus 4, or negative 16 minus, because initially it was a minus sign here, right? And then because I'm subtracting, it becomes plus. So negative 16 x squared minus a negative 4x squared becomes plus. So that becomes negative 12x squared. How many times does 3x go into 12x? So 3 goes into 12 4 times. X goes into x squared one more time. So that's going to be 12x squared. And then positive 8x. And then I'm subtracting, so this cancels out. And I'm left with 23 minus 8, which is 15. Bring down the negative 5. 3 goes into 15 5 times. 3 times 15 is 15. 5 times 2 is negative 10. And then I'm subtracting, so it becomes 5. So it did not divide in evenly. It's not a factor, but I did reduce my polynomial to this. And then I would write plus 5 over 3x minus 2. So this is my reduced polynomial. Okay? So a problem with long division is that it can be very difficult to do sometimes. So an option that makes it much easier is a process called synthetic division. And with synthetic division, what we're going to do is follow 3 steps. First of all, we're going to bring down the first coefficient for each term. So we bring down the 4, the -5, the 2, and the -10. Remember, if there's any polynomials missing, I have to replace it. Like if there's an x squared but not an x, I have to put a 0 in there. And then I'm going to multiply by the root. Okay? So here's the root that we're trying to do, right? So we're going to put a 2 here. So this is the factor. So the root would be 2. So we're going to put the 2 in here. So here's our steps. So we take this 4, we bring it down. Then we multiply by the root. 4 times 2 is 8, and we write that here. And then we add these 2 together. That's 3. And then we continue this process. 3 times 2 is 6. Add these 2 together, it's 8. 8 times 2 is 16. Add these 2 together, 6. So now I have broken this initial polynomial into x minus 2, parentheses, 4x squared, 3x, plus 8, with a remainder of 6 over x minus 2. So since I started with x cubed, my next step will be x squared. And then this is how I can, what we call, decompose the polynomial. Okay, so let's try another one. So I want to use synthetic division to divide these two. So my factor is x minus 4, so my root is 4. So I put the 4 here. I rearranged this polynomial up above with a 0 for the x squared. So I'm going to bring down, this should be it looks negative. It should be a positive 1, negative 2, 0, negative 7, and negative 110. So I bring down the 1, multiply these 2 together and get 4, add these 2 and get 2, multiply these 2 and get 8, add these 2 and get 8, multiply these 2 and get 32, add these 2 and get 25, multiply these 2 and get 100, add these 2 and get negative 110. Negative 10. So I've gone from an x to the 4th power to an x cubed. So 1x cubed plus 2x squared plus 8x plus 25 with a remainder of negative 10. So I write negative 10 over x minus 4. All right, let's try again. Synthetic division. So I have 4th power, 2nd power. I'm missing 1 power. So I have to put a 0 in here. The factor is x plus 3. The root is negative 3. So bring down the 6. 6 times negative 3 is negative 18. Add these together and get negative 22. Multiply these 2 and I get 66. Add these 2 together and get 66. Multiply these 2 and I get negative 198. Add these 2 and I get negative 181. Started off with x cubed. Now I'm at x squared. So 6x squared minus 22x plus 66 minus 181 over x plus 3. So now we have a couple of processes. One is called the remainder theorem. So the remainder theorem says if some polynomial is divided by a factor x minus c, then the remainder will equal p sub c, meaning if I substitute the root into p, I will find the remainder. So use the remainder theorem to find p sub c if c is negative 2. So that means that my factor is x plus 2, my root is negative 2. So I'm going to substitute negative 2 in this. When I substitute negative 2 in for all the x values, and then I do my mathematics, okay, I'll let you follow along, I get negative 10. So that tells me that negative 2 is not a root, and x plus 2 is not a factor. So it's telling me the same thing here for a half, which would be x minus 1/2. So I'm going to do the same thing. I put a half in for x. That's supposed to be a half. And then I do my mathematics, and I get 0. So what that tells me is that 1/2 is a root, and x minus 1/2 is a factor. Okay, so the whole point of what we're doing in Chapter 3 is to try and figure out roots and factors and find out what things are roots and what things are factors. Okay, so our last couple problems. So the factor theorem says, if a polynomial has a factor, if and only if the remainder is 0. So that means that when I did this problem back here, we talked about this one over here, that since the remainder was not 0, this is not a factor, it's not a root. Since the remainder here was 0, this is a factor, it is a root. So that's what we're doing here. So I want to know if x plus 1 is a factor of this polynomial. Okay, so x plus 1 is the factor, negative 1 is the root. I bring in the negative 1, the 8, the 22, the negative 29, the 24. Bring this down, multiply these two, get this number. Add these two, get negative 9. Negative 9 times negative 1 is 9. Add these two, multiply these two numbers, get negative 31. Add these two, multiply these two numbers, get 60. Add these two. This is my remainder. It's not 0. So therefore, x plus 1 is not a factor. I can always check this also with that theorem that we just did, and I can substitute negative 1 into the polynomial, and I get 84. Notice that these are the same number. Okay? So one more. Substitute in 3, and I put this in there. Bring down the 1, negative 5, multiply. Add these two, multiply. Add these two, multiply. Add these two, and I get 0. Since my remainder is 0, then that means that x minus 3 is a factor. Okay, and what have I also done? I've gone from x to the 4th power to now x cubed minus 5x squared plus 7x minus 8. I have now factored my polynomial, and I can continue to follow the same steps to factor it more.